Hello friends, in this video we will see about the group of order 12 and the group of order p square q where p, q are primes p less than q. Okay, let's see first group of order 12 and that has some relation with this thing p square q. Let's see group of order 12. It can be written as 2 square into 3, again p square q format. Anyway, we will discuss because it needed. Okay, so as we know that n2 denotes number of 2 Sylow subgroup in G, n3 denotes number of 3 Sylow subgroups in G. Okay, n2 congruent to 1 mod 2 and n2 divides the 3 other than the factor of 2, n3 congruent to 1 mod 3. You better see my videos about Sylow's statement review. There I gave complete idea about statement. I explained about statement which I am using here. 2 square here 1 or 3, but here 1 or 2 or 4. With respect to this equation, 1 is possible, 3 is possible. With respect to this equation, 2 is not possible, 1 is possible, 4 is possible. So we are in a situation like this: n2 and n3, 1 1, 1 4, 3 1, 3 4. And you look first 3 situations, somewhere we are getting 1, somewhere we are getting 1, so we are okay. At least in this case, a unique Sylow subgroup implies normal, and again this question is not simple. I have to produce a proper non-trivial subgroup, and in this cases we produce at least one of the Sylow subgroup which is proper and non-trivial because of prime order and which is not full order we produced. But a case here 3 and 4 where n2 equal to 3 and n4 equal to 4, we have the case, and I am saying that the n2 equal to 3 is not possible. Let's see, I mean it is possible, but there is a problem with that. Still we can get a, not problem, still we can get a Sylow, so not Sylow, some normal subgroup which is non-trivial. Similarly, let us take x equal to h1, h2, h3, this 2 Sylow subgroup, 2 Sylow subgroups of G, and G acts here like this: G H I G inverse by second Sylow theorem, theorem, we have transitive action. That is what second Sylow theorem is telling. This action is always well defined and this is transitive. That means we have a, okay, transitive anyway, that means we have a, always group action says that we have this thing here, the cardinality of set is true, we have this thing. So the kernel of phi, any group action gives rise to a homomorphism from this symmetric groups, and we have this thing. And this is here, look at that, here we are 6, here we have 12, so it cannot be injective. Injective is not possible, so kernel is definitely non-trivial, because kernel is trivial if and only if injective. The kernel is definitely non-trivial because 12 this side and codomain is 6. So the transitive says that it should be proper. That's what transitive I am using. Transitive, if it is not proper, suppose the kernel is a full, then the action is a trivial action only. So the kernel is not full because of the transitive action. Transitive ensures that this is not trivial. Okay, so in the group of order 12 we can still get a proper normal subgroup which is normal. Every kernel is normal, right? Normal subgroup which is non-trivial and proper, so we are getting. So order 12 is not a problem, which is not simple. Let's do for p order p square q where p q prime and p less than q. So similarly we will do np, nq, number of p Sylow, number of q Sylow, right? So np congruent to 1 mod p and np divides this q, whereas nq congruent to 1 mod q nq divides p square. Here we are 1 or q may be possible. Here q is 1 or p square. P is not possible. P is not at all possible because p less than q, so p square may be possible. But in that case, suppose nq equal to p square, that means p square minus 1, q divides p square minus 1, that means q divides p minus 1 q minus 1, sorry, p minus 1 p plus 1. But remember that q is a prime, so q divides p plus 1, because p itself less than q, p minus strictly less than q, so this is not possible. Q divides p plus 1, p less than q less than p plus 1. From here I am doing this, so that means p, the next, from here we can say that q equal to p plus 1 because the consecutive integers. Okay, I have a prime and I have a next prime, so one of the prime must be even, so the two consecutive prime, that says that p equal to 2, q equal to 3. I have a two consecutive prime, and there is no way in natural number if this happens, because every other number is even number, so only happens 2 to 3, that means p square q square equal to 2 square 3 is 12. So we have proved this. In the case of 12, this is not simple, otherwise it is not 12. This case is not, this is not happening, totally not happening, so it must be 1. So the upshot is nq equal to 1 unless the group order is 12. In that case this is simple, but we proved for 12 also individually, that is simple, so we are done. So the group action technique is so helpful, right? Okay, thank you. If you like the video, please like it, share it to many